Let's look at some of the radioactive decay dating methods. One of them, uranium-238, decays into lead-206. Well, what assumptions are involved there? Well, first of all, let's explain the process. The yellow circles that you see represent uranium-238. They decay into lead-206. And if you have some uranium, about half of that uranium will make the change in approximately 4.5 billion years. Well, that's the first thing. We assume a constant rate of change. We don't know that happened. We also have to assume that all of the lead that you see, the lead-206, came from the decay of uranium-238. We don't know that. In fact, we can actually show that we can get lead-206 from lead-204 by neutrino bombardment. We also have to assume that nothing is coming in or out of the rock. And that's not always the case, too. Rocks aren't as solid as we think they are. There's constantly water moving through there, and that water will bring in some minerals and take other minerals out. So something's being added or subtracted from the system. Now, what happens here? When we find out we have a lot of circles on the left and very few squares, if we date the rock at that particular spot, what are we going to find out? We're going to assume that that rock is very, very recent. But if we go to the other side of the rock and we see there are more squares, more lead-206 than we have uranium, we're going to assume, oh, this is a very old rock and dated in terms of billions and billions of years, aren't we? They have found that when they take samples on different faces of the very same crystal, they're coming up with completely different ages. That shouldn't happen. And in fact, the ages have a difference in some cases of 500 million years. That's a problem. So what do you do about that? Well, maybe you want to take an average. You end up taking the whole rock sample instead, and you find out how much uranium is in it. And you find out how much lead is in the whole rock. And then you get an average figure. And that sounds really good, but when your data points are so far removed, the average means absolutely nothing. For instance, what if I have one leg in a bucket of ice and another leg in the coals of a burning fire? On the average, I feel pretty good, don't I? Well, you see, the average doesn't mean anything when the data points are so far removed. So what assumptions are we making over here? We're assuming a constant decay rate. We're assuming a closed system, nothing coming in or out. And we're assuming the amount of elements present at the start for which nobody has any idea what they really were. All these things are very similar to the man digging the hole and the calculations we came up with.